Welcome to Elementary Functions. Today we're going to talk about graphing trigonometric functions. My name is Wendy Fresh. I'm from Portland Community College, and this is Math 112. So let's begin with graphing the sine and cosine function. Because the sine and cosine are functions, they have an input and they have an output. That means it should be possible to graph the functions on a rectangular coordinate system if the input and output can be identified. So let's think about this. The inputs of the sine and the cosine function represent and the thing that we've been inputting has been an angle. Sometimes that angle has been theta, sometimes that angle has been t. It can be really represented by any variable. So in this table of values, we should be able to input some angles, have the output be our y value, and then finally write the ordered pair. So just to be clear, we will call the angle theta. Therefore, we'll be graphing y equals the sine of theta. And our ordered pair will be that theta comma y. So we can really input any angle that we want. But in this case, I'm going to look at some of the more common angles. So I want to look at 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, 11 pi over 6, and finally 2 pi. That's certainly not all the values, but that's going to give me a good flavoring of that circle that we've been looking at. All right, so if I input 0 radians or 0 degrees into the sine function, y equals the sine of 0 is what? Now, to help us out a little bit with this, let's take a look at our unit circle. So we remember where 0 is, and if I look at the ordered pair associated with that point, it's 1, 0. That means y equals the sine of 0 is 0, and that creates the ordered pair 0, 0. How about pi over 6? Pi over 6 is associated with the ordered pair root 3 over 2, comma 1/2. And so my output is the sine value, and I get this ordered pair. For pi over 2, here I am, up on the positive y-axis, and my output is 1. So I have an ordered pair of pi over 2, comma 1. For 5 pi over 6, my output is 1/2. And so my ordered pair is 5 pi over 6, comma 1/2. For pi, I'm 180 degrees around that circle. The ordered pair is -1, 0 on the circle, which for my sine function gives me an output of 0. So on the rectangular coordinate system, when my angle is pi, my output is 0. For 7 pi over 6, I'm at an output of -1/2. For 3 pi over 2, I'm on the negative y-axis, so I have an output of -1. For 11 pi over 6, I have an output of -1/2. So my ordered pair is 11 pi over 6, comma -1/2. And finally, making my way around the circle at 2 pi, I'm at the same place that I was with an angle of 0. And so this is where I see the repeat. So now what we want to do is plot these points on a rectangular coordinate system. So here's the table of values that we created, and what I'm going to do now is take those ordered pairs and plot them on this rectangular coordinate system. You'll notice that along my horizontal axis, I've labeled that as theta, so all of those horizontal distances will represent angle measures, and then the vertical axis I've labeled y, so those will be my outputs. In other words, those values will be what the sine of the angle is equal to. So let me start with the point 0, 0, and that point is of course at the origin. And I think I'll go through and I'll mark the points that actually have tick marks on my axes. So the next one would be the point pi over 2 comma 1. I'm going to go over to pi over 2 and I'm going to go up to 1 and put a point. The next one would be pi comma 0. So I'm on that horizontal axis. 3 pi over 2 comma negative 1 is going to be right here. And then 2 pi over 0 puts me back around that unit circle. Now, the other points are all in sixths. So what might help me in determining where those belong is to think about how many sixths pi over 2 is. In other words, pi over 2 could be called 3 pi over 6. And pi could be called 6 pi over 6. And 3 pi over 2 is 9 pi over 6. And 2 pi is 12 pi over 6. So we're just working with fractions. And let's see, does that help? Pi over 6 then is going to be between 0 and 3 pi over 6. It's going to be less than halfway. And so I might just estimate that let's see, each one of these points on the y-axis looks like it's 0.2, so 0.2, 0.4, 0.5, maybe, I don't know, around right here. It's an estimate. 5 pi over 6 is going to be closer to pi, or 6 pi over 6. And so maybe I will put that about right here. Again, I'm just estimating. 7 pi over 6. Negative 1/2, that's going to be also close to pi, and I'm going to go down, so maybe about right there. And then finally 11 pi over 6 is going to be closest to 12 pi over 6, but still down at negative 1/2. Now, because a circle does not have a constant rate of change, in other words, it's not a square. It goes around the circle, points go around that circle in an arc motion. I'm going to connect these points not with a straight line, but with maybe more of a curve. Now, if I'm having a hard time seeing where to connect these points, I can always plot more values. But I'm getting a picture that looks something like that. Let's see if I'm right on the next slide. And that looks pretty good. So that is using Desmos to plot the point. And from this graph, we can identify a few things. We have a definition here. The definition is that the midline is the horizontal line midway between the function's minimum and maximum values. So my maximum value is 1. And my minimum value is negative 1. So the midline of the sine function is the line y equals 0. And I can draw that in if you would like, maybe with a dashed line. That's going to be my midline. The next definition is of the amplitude. And we say that the amplitude is the distance between the function's maximum and minimum value and the midline. Because distance is always positive, the amplitude is also always positive. So from that midline of y equals 0, I go up 1 or I go down 1, and that tells me that my amplitude is 1. All right, so now let's take a look at the cosine function. We will do the same thing with the cosine function. The inputs of the sine and the cosine function are represented by an angle, and we're going to let that angle be called theta like we did before. So we're looking for cosine of theta, and we will be plotting the points theta comma y on the next slide on an xy axis. So like we saw before, I can put any angles that I want in for the cosine. I'm going to pick some from 0 all the way down to 2 pi. And let's see here, I'm going to put in, I did pi over 6s before. Let me use pi over 3s this time. And I'll do pi over 2. You can do whichever ones that you want. You'll just get different ordered pairs from me, but when we connect them with a nice smooth curved line, they should match up. All right, and I've got my circle off to the side, my unit circle. And so let's see if that helps me. Now, we really should be able to do this without that circle, but this will help us go a little bit faster. So what is the cosine of 0? The cosine of 0 is 1, and so that gives me the ordered pair, 0, 1. What is the cosine of pi over 3? That is 1/2. And so pi over 3, 1/2 is another point. Up at pi over 2, which is like 90 degrees, my cosine is 0. For 2 pi over 3, I am at -1/2. At pi, I'm at -1 for the point pi, -1. At 4 pi over 3, I'm at -1/2 again, just like I was at 2 pi over 3, so I'm seeing the symmetry. 3 pi over 2, I'm at 0 for the ordered pair 3 pi over 2, 0. At 5 pi over 3, I am at +1/2 for the point 5 pi over 3, 1/2. And finally, making my way around to 2 pi, I'm back at 0 for the point 2 pi, 1. All right, so let's take those points and plot them on the xy axis. All right, so there's our points, and I think again I will plot the ones that I have a tick mark for on that theta axis. So 0, 1 is right here, 1 unit above the x-axis on the y-axis. The point pi over 2 is on my one of my tick marks. So pi over 2, 0 puts me right on that horizontal axis. I'm going to go out to pi and then go down to -1. At 3 pi over 2, I'm at 0. And finally, at 2 pi, I'm back up at 1. Now, I bet you can almost see that shape. Based off of the curve that we saw last time, I'm thinking that maybe you have a guess as to what the curve looks like. But let's just make sure. Pi over 3, where is pi over 3? Well, pi over 3, let's think about what we did before. Last time we broke everything into units of 6, and we said that pi over 2 is the same thing as 3 pi over 6. How many units of 6 is pi over 3? That would be 2 pi. So pi over 3 is just a little bit to the left of 3 pi over 6. So I'm going to estimate, like you saw me do before, and that's going to put me up at about 1/2, something about like that. And 2 pi over 3, let's see, 2 pi over 3 is the same thing as 4 pi over 6. So just on the other side of 3 pi over 6, I'm at 1/2. I'm sure you can see that. 4 pi over 3. 4 pi over 3 is 8 pi over 6. So let me see here. 8 pi over 6. 3 pi over 2 is 9 pi over 6, correct? So 8 pi over 6 would be just a little bit to the left of that. And I'm down at 1/2. So maybe like something like that. All right, and the last one, 5 pi over 3. 5 pi over 3 is 10 pi over 6, so just a little bit to the right of 9 pi over 6, and I am at +1/2. And I just saw a mistake that I made. It looks, do you see the mistake I made? I got so busy graphing 1/2 that it looks like when I graphed this point, 2 pi over 3, -1/2, I graphed that as positive. So this point should be gone, and it should become 2 pi over 3 negative 1/2. So maybe something more like this. So I'm going to just cross out that mistake. All right, now let me connect the correct points with a nice smooth curve. And I get something like this, I hope. That looks pretty good. Always want to put arrows on the ends. And let's see if we're correct. Ah, and there it is. It looks good. All right, so we already know what the midline and the amplitude are, and we determined what those were for the sine function. How about the cosine function? What's the midline? Has anything changed? And one way of finding that midline is to look at what's your highest point, what's your lowest point, and then meet those in the middle. So I think that we are still at y equals 0, and I think our amplitude is still 1.